Today, we'll talk about what watersheds are and why they're important to all living things. This lesson was made by Ivan Caballero, Mariah Thrush, and Joss Minich as part of Ohio University's NSF-funded Boat of Knowledge in the Science classroom. Water flows downhill due to gravity. When it rains, where does that water go? Pause the video and come up with a quick list of possibilities. Some rainwater will soak into or infiltrate the ground. Water that doesn't soak in will flow across the land until it reaches a stream, river, or lake. If we know the location of the rainstorm, can we predict what body of water the rain will end up in? In short, yes, we can predict this with the help of watershed maps. A watershed is the area of land where all of the water, including rain, snowmelt, and groundwater, flows into the same stream, lake, river, or bay. This land feature can be identified by tracing a line on a map along the highest elevations between two areas. The watershed divide, also known as a ridgeline, is the top elevation of a watershed that separates watersheds. In this diagram, we can see the watershed divides on the outer boundaries of the picture. Any precipitation that falls within the divide will flow into the tributaries, which lead to the main river. As mentioned, some water will soak into the ground and enter the groundwater or aquifer. This process is called percolation. Bigger watersheds can be divided up into smaller watersheds, called subwatersheds. You can think of these subwatersheds as puzzle pieces that fit together to make a larger watershed. When two subwatersheds meet, they connect by a confluence, which is the meeting of two or more bodies of water. Here's an example of a confluence, where the Milk River and Missouri River meet. There are 2,267 watersheds in the U.S. These watersheds combine via confluences to make 15 major U.S. watersheds. To see how watersheds fit together, let's start with a small watershed. The Muskingum River watershed is entirely in the state of Ohio and drains into the Ohio River. The Ohio River watershed spans across 12 states and drains into the Mississippi River. The Mississippi River watershed is made up of 6 watersheds, including the Ohio River watershed. This watershed drains into the Gulf of Mexico and Louisiana. All watersheds combine at confluences to become larger and larger watersheds. You know the basics of watersheds, but why are they important? Pause the video and talk with your classmates. You probably learned the water cycle, also called the hydrologic cycle, in elementary or middle school. All of these steps, from precipitation and infiltration to evaporation and condensation, occur within a watershed. Water is continually moving through watersheds, and all of our fresh water comes from precipitation that is eventually stored in watersheds. Surface water, such as water stored in lakes and rivers, has a connection with groundwater. Surface water seeps into the groundwater to recharge the underground water supply. And groundwater can also flow up into surface water bodies when bodies of water are particularly low, but the groundwater level is still high. 80% of our drinking water systems rely on groundwater resources, but most of the U.S., that is 66%, use the 20 remaining percent of the system serviced by surface water. This means that surface water is a precious resource for the U.S., but we do have problems with pollution of surface waters. What do you think is the most common cause of pollution in streams, rivers, and oceans? Take a moment and choose one of the 4 answers. Surface water running off yards, streets, paved lots, and farm fields contain many pollutants that enter the bodies of water and can enter into our drinking water supply. Though there are a wide variety of pollution sources, precipitation runoff from farms, lawns, and paved surfaces are the leading source of water pollution in the U.S. today. What's in the polluted runoff? A whole suite of pollutants, including fertilizers, herbicides, insecticides, oil, toxic cleaning products, sediment, road salt, and air pollutants that have dissolved into the water, among many others. Floods can lead to increased levels in pollutants when water comes into contact with materials we don't intend to get wet. A flood is defined as any time a water body overflows or when an unusual amount of water collects in dry areas. A flash flood is a specific type of flood that is even more dangerous. During a flash flood, waters rise to flood conditions very quickly, within 6 hours or less. This means people have less time to prepare, and there's a greater possibility that pollutants will enter the waterways. Flash floods are typically caused by large, intense storms, but they can also happen due to a dam or levee failure, as seen in this picture. Urban floods occur because there are so many paved surfaces in a city, meaning that water can't seep into the ground. The water has to go somewhere, so it floods the paved surfaces, eventually running into the nearest stream or the lowest lying area. There are some simple ways you can help protect the watersheds around you. Don't dump or litter. Conserve water by choosing landscaping plants that need less water. Clean up after your dog. Check your plumbing for leaks. And volunteer with local watershed groups to clean litter in and around streams. Now that you know how to take care of watersheds, let's talk about how to find them on maps. Most maps you see are two-dimensional, but watersheds are three-dimensional structures. Maps pictured here show the height of a landscape, but what if a map doesn't look like this, but looks more like this? These are the type of maps we use to understand where watersheds are by finding the highest points and lowest points to find watershed borders. These type of maps are called topographical maps. I've highlighted some of the contour lines on this map. Purple lines denote an 800-meter elevation, yellow a 900-meter elevation, and red a 1,000-meter elevation. These elevations are meters above sea level, so the elevation at the beach would be at 0 meters, while mountains can be thousands of meters above sea level. As we learned before, the highest points in a landscape are watershed boundaries, while lowest points are where water collects. With topographical maps, we can also tell how steep the land is. In box 1, the 1,000-meter contour line is far away from the 900-meter contour line, meaning the land slowly slopes. In box 2, the contour lines are close together, meaning that the elevation is changing quickly over a small area of land, resulting in a steep hill or mountain. In steep areas, water will tend to run off the land and into streams rather than soaking into the soil. For a hands-on experience, go to the Wix website listed here and download the instructions to make your own watershed out of modeling clay. Thanks for watching.